Hello, my name is Gabriel, and in this video, we will create enough test data to test our application. The problem that we are facing is that we need 200 rooms, and each room should have 1 to 6 guests. The 200 rooms, it's an easy problem. We can ask the LLM to generate data for us, or we can use a library designed for data generation. That is not the difficult part. The difficult part is how we segment and how we handle the number of guests and duration of reservation. What we have or what we need in reality is a green line is today. But in reality, a reservation starts from today lunchtime onwards or ends with today's breakfast. So comes from the left. So we don't really need today per se. We need less than today, but including more than today, excluding. There is also the case where a reservation spans for multiple days, and today is included. So we have these three cases. Under these three cases, we have some extra cases for errors. The errors we were talking about would look like this. So this is today once more. We have the date of the reservation that spans until breakfast. However, the status of this reservation, instead of being checked in, is checked out for some reason. Or the other way around, where the date of the reservation starts from yesterday, but the status of the guest is still checked out for some reason. This is another synchronization problem. We also have starting from today lunchtime onwards, but somehow he appears to be checked in. This is borderline error, can be also considered as the use case where the user, so I'll make two arrows here. The guest has arrived at the hotel at 8 p.m. or something. His room was empty. However, he does not have breakfast for today. So yes, he is checked in for the meaning of today. However, he is not checked in for all the services of today. His services start from 12, the hours established by the hotel. We also have another case. These are the most common cases when it comes to check-ins and check-outs. The discrepancy between check-in and check-out and all these error cases is that in case of miscommunication between systems, we don't know which one is the correct information. It is the date or it is the status. We don't know which one was sent and which one was not sent correctly. In this case, the source of truth, it's actually the hotel. No matter what the integration partner says, if the human is still inside the hotel and the human should be served, the human will be served. The synchronization will be solved later. Yes, it is a hassle, but the hotel is the one that is correct in all the situations. So how we should go about this problem is midnight. Then the hotel should have a range between check-in time. The user starts to be able to access different services. It is not only breakfast, it can be also pool and things like this. So everything that goes after the check-in time can be considered as a service. What is in between check-in and midnight, we can call it a buffer. And what it is before midnight, but after the last check-in date, is considered a service period where the people that already existed and are there, because everybody who stopped before, so when they checked out, even though that the day is still ongoing, they do not have access to things anymore. And everybody who checks in has access only to the things available after this hour. So in reality, when we generate the test data, we should generate two different intervals. Now, in order to simplify everything, we can consider that the staying period actually lasts until the buffer has ended. So the new staying is here, and a new reservation exists from this buffer onwards. Today, for a hotel, it's slightly different. The midnight has not much of an impact. Today, it's actually the check-in and check-out hour. Now, there is and there will always be a delay between staying and new reservation. That is the cleaning period. So in reality, we will have staying, then there will be cleaning, and then there will be new reservation. And here we can see the purpose of this project, because we are talking about two different timelines. A guest that comes to our hotel does not care about the cleaning period. This cleaning period is relevant only for the hotel. To what you get when you're trying to check in at a hotel where the cleaning has not been done, you're being told to come later. That's all. It is not something that you care about. And in this cleaning period, you usually are offered some services. I don't know if you're going to be offered exactly spa, but for sure you can leave your luggage there. It depends a lot on how the hotel wants to consider this, if it is an extra service or not, but it must exist. So therefore, this is our interval. We need to expand our database to have information on room level, which state the hour at which new reservations are accepted for that room. The reason why this is important, it is because there are the reservation types. So if we remember from our last drawing, if this is today, we had reservations over, we have reservations starting from now on, and we have reservations until, and they are in different statuses. Therefore, on top of these arrows, the top arrow actually is split in two. We have special reservations for employees that stay for a long period of time and span over a cleaning period, but they don't have access to services, and we have normal reservations that span over a period of time, but they do have access to services. So there are four types of reservations and three types of intervals. We have to write these down in a prompt in order to make sure that we have all the information in our database. We know for sure that we do not have information about the reservation time on room level. There is a choice to be made to have this information on hotel level and apply it only to normal rooms, not special rooms, or to have it on room level. Here there is a little bit of performance impact. We can take out more space and duplicate the information on room level and have more granular control, or we can take up more computation and have this information in a different table, only store the information for the special rooms. Everybody else obeys a hotel override. In order to make things more clear, let's consider that this is 3 p.m., this is 9 p.m. Now there is one more thing to be taken into consideration. If we make this data static, it will not work if we have a dynamic display, because tomorrow it's a new date and tomorrow will not obey anymore this interval. Tomorrow, whatever we had today as a new reservation, they will be staying reservations already and they might check out. So the data generation has to be twofold, or at least twofold. One, we need a list of names, room names, and dates and hours. And the second part is a dynamic script in which we re-update all the rooms and all the guests with our new dates. If we do it like this, and if we don't regenerate the customers all the, it is much simpler, because by working with this project more and more, we will learn the names of the customers and the rooms they are checked in or they will be checked in into, and it is easier when we have to manually validate some, or when we have to add new test cases. If we write a fully dynamic script that every time regenerates everything, it will be very tedious to find test values that we usually need. From all these values, not all of them are useful, because some of them are there just to generate load when there is a query or when we need to calculate the data. If our hotel has 200 rooms, this is almost not the case that all the rooms have to be checked in the same time. Also, it is impossible because we have considered that we have 3 receptionists. So only 3 rooms can be checked in at once. In order to make sure that we generate enough load for parallel requests, let's say that we will check in 6. 3 of them will be checked in manually, and the other 3 will check in by themselves via some other application. For checkout, since there are only 3 receptionists, we cannot check out more. In the case of checkout, some things will be added on the room automatically, like cocktails or things like this. They have to be paid at the end. When it comes to testing the check-in and check-out process, we can safely assume that for check-in we need maybe 6 in parallel, and for checkout we can do 3 at most. We will ignore the overlap in which a receptionist is doing a check-in and the other 2 are doing a checkout. We are trying to write enough tests to stress the system as much as possible. Thank you very much, and see you in the next one.